I'm going to be talking about the present value of a compound interest problem. Now, the general equation or the general formula for compound interest is A equals P 1 plus I to the n, where A is the future value. So if I was looking for the future value, this would be the formula I would use. Now, what I'd like to do instead is compute the present value of a compound interest problem. So instead of solving for A, the future value, I'd like to solve for P, the present value. We can take this general formula and rearrange it to look like this instead. So just rearranging it, we can have P equals A divided by 1 plus I to the n. The values in both equations mean the same. They have the same meaning. So if I'm looking at this equation, P is the present value, or the principal amount of a loan or an investment. A is the future value, or the maturity value of a loan or an investment. I is the periodic interest rate, but we want periodic interest rate. So I would be how much interest is added every period, every compounding period. So if the question had semi-annual compounding, that would mean that there would be 2 compoundings a year. So if I'm looking for I, it would be the annual rate divided by 2 compoundings a year for semi-annual. So really, to find your I, you're going to take the annual rate and divide by the number of compoundings per year. The n is the total number of compoundings, now it's not the number of compoundings per year, it's the total number of compoundings for the entire duration of the loan or the investment. So if the loan or the investment is for 5 years, then you would take those 5 years and multiply it by how many compoundings per year your interest is added. So you would say if it's 5 years and quarterly compounding, you would multiply 5 times 4 to give you 20 compoundings in total. So to find your n, it'll be the number of years multiplied by the number of compoundings per year. So those are all the meanings of all of the variables in the equation. So now that we know the general equation, we're going to use that and try an example. So look at this example. Jason would like to save up $30,000 for a down payment on a home. What lump sum would he need to invest today in an account earning 5% interest compounded semi-annually in order to reach his goal in 5 years? So our general formula for solving for the present value is P equals A divided by 1 plus I to the exponent n. We're looking for the present value because we want to know how much does he need to invest today, presently. We know in the future he would like to have $30,000 saved. So our value for A, the future value, is $30,000. We're going to divide that by 1 plus I, the periodic interest rate. To find I, remember, we're going to take the annual interest rate and divide by the number of compoundings per year. So the interest rate is 5%, and I'm going to divide that by 2 because we have semi-annual compounding, which means twice a year the interest is added to the main amount. So this will be 0.05 divided by 2 which will give me 0.025. So that's what we'll put in for I. Now the exponent n is the total number of compoundings. So to find n, it's going to be the number of years, which is 5 years that he's going to take to save up the money he needs, multiplied by the number of compoundings per year, which, since it's 5% compounded semi-annually, it's 2 compoundings a year. So that means in total there will be 10 compoundings. So our exponent there, n, is 10. Now to actually compute this, we have to do the correct order of operations, which is brackets first. So we'll be adding inside our brackets first, 1 plus 0.025. Once we've added that amount, we can take it to the exponent 10, do that exponent next. Once you've computed the exponent value, then you can take 30,000 divided by that value. When you divide it, you get a final answer, $23,435.95. So that would mean that Jason needs to have $23,435.95 in an investment account today, so that in 5 years, earning 5% interest compounded semi-annually, he will have the $30,000 needed for the down payment on his home.